Hi everyone, thank you for joining us for today's webinar where we'll be introducing KantanNeural. Before we begin, I'll quickly go through a few housekeeping details. The session will be recorded and shared with all registrants. After the 30-minute presentation, we'll open the floor for a 10-minute Q&A session. You can type in your question in the chat box at any point during the presentation. We have some exciting new developments taking place at KantanMT, and we are very lucky to have two experts in the field to talk about neural machine translation today. While I'm sure everyone here is acquainted with Tony and Dimitar's work, I'll briefly introduce them to our audience. Tony O'Dowd is the CEO and Chief Architect of KantanMT. He has more than 25 years' experience in the localization industry and has previously held senior positions at Lotus, Semantic, Coral, and Alchemy Software Development, which he founded in 2000. Dr. Dimitar is head MT researcher at KantanMT and leads KantanLabs, a research group committed to advancing language technology. He holds a PhD in computer science from KU Leuven in Belgium. He has worked on design and development of AI software for learning and reasoning with uncertain data and is currently researching application of neural network technology on KantanMT platform. Now, without further delay, I'll hand the mic to the presenters for today. Thanks.
Thank you very much, Palumi, for that introduction, and good afternoon to all of our attendees today. My name is Tony O'Dowd, and I'm the CEO and founder of KantanMT. So what we're going to do today, guys, is we're going to give you a quick introduction into KantanMT. Then we're going to move swiftly on to discussing what is all this exciting news about KantanNeural, what it is, what's the difference, I guess, is one of the first questions everybody asks me when we talk about our new feature. What's the difference between SMT and NMT? And Dimitar is going to explain that in a number of very succinct slides later on today. In conjunction with the release of KantanNeural, one of the biggest challenges that people are facing is how can they evaluate the improvement in translation quality. And since we don't have automated measures such as BLUE, FMeasure, and TER that really makes sense when you're working with neural systems, we've also developed a new feature in KantanLQR. LQR stands for Language Quality Review, and it's called A/B testing. And we're going to show you that feature today to give you a sense of how you can actually build your own NMT systems and then evaluate the translation quality to validate that the translation is actually better than statistical machine translation systems. And then we're going to go quickly into a Q&A session. So that's for the agenda today. So we have quite a lot to get through, so I'll move swiftly on. So what is KantanMT? Well, KantanMT is a statistical machine translation platform. It's cloud-based, but a number of our clients don't use our cloud, they use their own private cloud. So we have multiple ways of actually configuring the software. So you can use our cloud servers or you can use your on-premise servers as well. It's a fusion of translation memory technology and machine translation technology with a load of rules that really boosts up the quality of the output translations. And of course, today we're announcing that we also have a neural MT capability as well built into the platform, which means anybody worldwide, all of our clients worldwide can now start experimenting with neural, which is a great new feature, I guess, and certainly it's giving them a sense of what the future holds in our software. Our vision in development upstairs in our development team is to do three things really well. It's to help you customize engines, it's to help you improve those engines and help you deploy those engines. And believe it or not, when we're having development meetings upstairs, that's what we focus on, those three activities. Can we improve those three activities? Customization, improvement, and deployment. So far on the Kantan platform, we have over 10,000 engines. The vast majority of those are statistical, obviously. And our clients, which from all over the world, have uploaded over 534 billion words of training data, and so far we've translated 8.5 billion words this year. So where do we translate those words? Well, if you look at the breakdown of our word translation rate last year, the majority of the words come from the e-commerce sector. We have a number of really big clients in the e-commerce, and the two biggest e-commerce platforms in the world today, including Alibaba, are translating on the Kantan platform. Obviously, we do a lot of technology companies, and then we have other stuff such as legal and medical translations going on as well. Here's a quick list of some of our clients. It's not an exhaustive list, but it just gives you a sense of how wide and how deep our client base is. It ranges from large LSPs to medium-sized LSPs to small software companies all the way up to the big software companies as well, and lots of e-commerce players in between. We have a very, very active academic partner program, and today, in fact, KantanMT is delivered as part of the course curriculum in 28 different colleges worldwide, and we were delighted only in the last 6 weeks to sign up 2 colleges, universities that are based in China. China is a big area of growth for us at the moment, and we're delighted to have 2 Chinese universities have started to teach their students how to use the Kantan platform and how to build statistical and, in the future, neural MT systems as well. And we also have a number of memberships to a number of well-known industry organizations, such as ADAPT, which is on the same campus as us. We've done a number of projects with ADAPT over the years, and obviously various other organizations as well. So there's only 3 things that we do. We help our clients build engines, and in order to do that, we have developed a large range of technology components that sit on the Kantan platform, and we operate behind the scenes. So our clients don't really configure these components, they're auto-configured for them. So in other words, if they need named entity recognition, the system automatically switches that feature on and allows them to start using those features. In addition to that, we have a whole range of technologies that's used to help them improve the quality of an engine. So it's relatively simple, guys, to build your baseline engine. There's no real kind of novelty there anymore. Most people have adopted a similar approach to what we've adopted. You upload some training data, some monolingual data, maybe some terminology, and you can pretty much build an engine which is a baseline engine. But the real challenge is, how do you take that baseline engine and get it to the level of production quality? And that's what really makes a difference to our clients. So we've developed a whole range of technologies, such as an interactive development environment called Kantan Build Analytics, to help them see the improvement of their engines and to manage that process of building the engines. And the really key thing there is that we've done it in an interactive way. So it's like using, Visual Studio when you're building C++ applications. You use Build Analytics to build high-quality engines. And then we have another range of technologies to help our clients deploy those technology at scale in the cloud. So, our clients don't use a single server. Typically, our clients use multiple servers for multiple language arcs. And in fact, today, across the Kantan platform, we have approximately 700 servers running the actual service for all of our clients 24/7, 365 days of the year. So that just gives you a quick rundown on the Kantan platform. So what we're going to talk about today, guys, is this little box down the bottom of that particular diagram called KantanNeural. Okay, so I'm going to pass over here to Dimitar, and he's going to talk about some of the exciting developments in our pipeline, which are available today or will be available, I think it's next Wednesday. I think it's the release date. So we're getting very close, and we're all very excited about this. So I'll pass over to Dimitar now, who will talk more about KantanNeural.
Hello, everyone. My name is Dimitar, and I'm heading the research department at KantanMT. As Tony said, we are constantly focused on improving our platform, and one of these improvements is indeed in the introduction of KantanNeural. KantanNeural is the system within KantanMT that helps you build and customize neural MT engines. First, let me talk a bit about SMT. So to go back a bit in history and say how we started, how an SMT engine is built and how it is used to translate. And then I'll move to the neural networks so that we can have a clear picture of the differences between the two. So basically, statistical machine translation is the paradigm of machine translation, which concerns translating phrases rather than single words, and organizes the translation following a statistical model. So in order to do that, it generates a phrase table, which means that it's a dictionary of phrases. Each of the source site is translated into a phrase on the target side, and usually these phrases are associated with some probability. Here you can see an example. I have omitted the probabilities just to make it a bit simpler. And when we have this phrase table, which is learned from parallel data, we combine the phrases in a way that maximizes the probability that indeed the outcome is a translation of the input sentence. So it's like Lego blocks that we join together, and then we try to maximize the likeliness of this sentence being the translation of the original sentence. Now, SMT has been around since like 7-8 years now. A lot of commercial MT providers use SMT. That's the state of the art. But SMT has already reached a point where it cannot respond to the high demand of for translation. And also, SMT lacks, let's say, some plasticity, and it often requires human intervention. In order to tackle some of the problems of SMT, researchers have come up with the use of neural networks, artificial neural networks, for machine translation, or the so-called NeuroMT. The most famous NeuroMT architecture is the one that uses recurrent neural networks. Recurrent neural networks have the ability to store, to memorize information, and that leaves us the possibility to introduce large sequence of words rather than predetermined size of words. So we can introduce sentences that have that are of small size, 1-2 words, or very large sentences of 40-60 words. For NeuroMT, there are no more phrases. The concept of phrases is gone, basically, and you have sequences of words that are actually represented as vectors, because neural networks, they use vector representations to learn from and produce results. So the typical neural machine translation architecture is based on the encoder-decoder with attention mechanism. So I will just briefly say about the encoder-decoder. So basically, you have the encoder which takes an input sentence, let's say in English, generates a vector that is a hidden intermediate vector, and then you have the decoder which learns how to translate this vector C into an output in, let's say, French. So it's rather simple idea, but behind it there are a lot of mathematics, a lot of smart ways to integrate, to implement efficient systems. That's because, as I said previously, words are not represented as words anymore, but rather as vectors. And these vectors can be very huge. Using vectors to perform some operations requires quite some computational power. In order to use words as vectors, we have to be smart and intelligent how to divide these words in such a way that we limit the size of these vectors, and also in order to solve the problem of unknown words. Because while SMT would just move one source word into the target site if it cannot translate it, NMT often can generate unexpected results. Like it can represent one number that it hasn't seen as a completely different number. And so in order to solve this problem and also to limit the size of the vectors, we use two smart techniques. One of them is called the byte pair encoding, which splits a word into several subwords, and the other one is single character engram, which actually will consider every character as a separate unit, and will train on this unit. So based on all these features, we in Kantan have built our neural system, so KantanNeural. As I said, it is computationally expensive to train on huge data represented as vectors, and that is why we use GPU machines we use GPU machines on the cloud, and there they form a grid, and that allows us to use a lot of GPU power and train very fastly and translate also very fastly. The architecture of Kantan is quite modular, so that's a great feature, and we can actually introduce neural engines very, very easily to our system. It is highly distributed, and because of that, it's highly efficient. In our implementation, we have considered two types of tools. The one is based on Peano, a well-known deep learning toolkit, and the other one is based on Torch. We have run experiments, and we have determined that OpenNMT, the Torch-based tool, is very fast, and it has a large development community, and that's why we have selected this one as our core technology around which we built our KantanNeural. And so, as yesterday it was SMT in KantanMT, today we have several engines that are ready to be deployed, and as Tony said, from next Wednesday we're planning major releases and allowing people to customize their engines. Now I'll head back to Tony.
Okay, thank you very much, Dimitar. So the news there, guys, is that as of today, clients worldwide using the Kantan platform, in fact, as of the last 3 or 4 weeks, they've been able to translate using neural engines, neural MT engines, because we launched neural engines several weeks ago. But as of next week, our clients, for the first time ever, will actually be able to adapt engines using neural technology. So one of the biggest challenges, of course, is how do we quantify the improvement in translation between neural MT and statistical MT. So what I'm going to show you here is a new technology called KantanLQR. Now, just as an aside, by the way, I just forgot to mention this actually, Dimitar just brought it to my attention that if you wanted to select a neural MT engine today on the Kantan platform, it's really, really simple. All you do is you actually click on the fleet button, and when you select fleet, you're asked what domain you want the engine to come from, and at the bottom of the domain list, you'll see a domain called neural MT. So you'll be able to select neural MT, and then from that list, you'll be able to select different language pairs and so on. Alternatively, if you have a statistical engine and you want to change that engine from statistical MT to neural MT, all you do is you select the properties of that engine and actually switch the engine type dynamically. Okay, so that will switch from statistical MT to neural MT and so on and so forth. So you've got lots of flexibility here in how to do this. So how about the quality of these neural MTs? Well, the first phase of development, we ran a number of tests. Now, the first thing we had to do in terms of testing was we didn't want to compare different engines because you're not comparing like with like. So what we said was, let's build an SMT, a statistical engine, with a certain data set. Okay, that was a data set that we know, so that's a canonical data set. We then said, let's build exactly the same engine with neural technology using exactly the same data set. And now we have apple by apple conversion. We can compare a statistical engine to a neural-based engine. So rather than go and compare it to 3 or 4 different manufacturers of engines, we said, let's keep it a more isolated test so we can truly see the difference. And I have to say, here's the results of our first attempt at this. And we were a little bit shocked, to say the least, because we were hearing this anecdotal evidence that, you know, the blue scores of NMT and the quality of NMT would be far superior to SMT. And you can see here that that's not the scores we got. However, when we did human evaluation, we found out that the blue scores were not really telling us the full story. Okay, they were hiding the quality of the engine, because if you try to compare the output of a neural engine to a statistical engine using either F-measure blue or TARE, you're not really getting the full story. So our first test on this, we were a little bit disappointed in the results, but it actually proved a point that blue is not really suitable or adaptable to NMT. So there has to be a different way of measuring the quality of those engines. And why is that? Well, here's 3 good examples that Dimitar got earlier on today. So on the left-hand side here we have, this is German translation, and on the left-hand side, and then on the right we have English translation for that. And you can see that the original source text, which has just appeared there on the right-hand side, gives you a sense of that neural translation. There is no resemblance to the output of a phrase-based system. So if you look at the neural translation, the English of that is the range therefore represents an overestimation of production, which is actually a very, very good translation. It's a different translation to the original English, which is over on the right-hand side of the screen, and you can see why blue would completely break down in measuring the differences, or measuring the similarities rather, between those translations and a reference translation. So we had to come up with, we came across a barrier here that we had to resolve very quickly, because we really want to know how good these engines are. So what did we have to do? Well, we had to look at a new way of looking at translation quality evaluation. And we have a platform built into the Kantan, into everybody's account, called KantanLQR. LQR stands for Language Quality Review. Everybody in the world has access to this. And it's an integral part of the current development process when you're building statistical engines. Now, let me step back a little bit, because if you're building a statistical engine today, and like a 1 billion word engine would take approximately 6 weeks to deliver to a client. It takes about 6 weeks to build that type of engine, okay, and get it to production level quality. Interestingly enough, only 2 weeks of that 6 weeks time frame is engineering time. The other 4 weeks of that is engaging with professional translators to evaluate the output of the engine. And by analyzing that, the output and the feedback from that professional translator, we can fine-tune the engine, improve the performance of the engine, and eventually get it to production quality. So it's not a case of just uploading your data, hitting the big green button, and wham, you get an engine out the back end. You've got to get human translators, professional translators involved in the development. And in fact, our best engines today have been delivered using that mechanism. We have a very systematic, step-by-step approach that we use to building statistical engines. And lo and behold, when we started working with neural engines, we found that we needed a different type of testing. Okay? And that type of testing was integrated or introduced into KantanLQR as a new project type called A/B testing. So the current version of KantanLQR provides a project type called quality evaluation. So that allows you to create a language quality evaluation project based on a factored models. We use key performance indicators, KPIs, which are based on the MQM framework. We also support the DQF framework and the harmonized MQM-DQF framework as well. And that allows our clients to look at the fluency of the translation, the adequacy of the translation, the grammatic, syntactical, the morphological aspects of the translation. So that's kind of on the left-hand side of this slide is the traditional way of evaluating translation. And in fact, we use that very effectively to feed it back into a statistical engine and improve that engine. But of course, we now want to know the difference between a statistical engine and a neural engine. So we need to do A/B testing. That's what the industry kind of calls this. We've all heard of A/B testing. When you put a new widget on your user interface and you track who's using it, who's not using it, you do an A/B test. So we've brought this concept of A/B testing for translation, which is not something that we've invented. It's kind of fairly well known. Again, it's based on having a sample A and a sample B. And what you basically do is you ask the translator to decide, is sample A better than sample B, okay, based on a reference translation. And by monitoring what they do, you'll get a sense that sample A is better than sample B. And if sample A came from a neural engine, you can take an inference there that the neural engine is outperforming its statistical engine. Now, of course, Kantan being Kantan, we don't just stop at A/B testing. We also provide ABC testing and ABCD testing. So you may want to, for instance, compare your neural engine against the equivalent statistical engine that you've been using for the last 2 or 3 years, and maybe throw in maybe an open comparison to say Google Translate or Bing Translate, and the system will just automatically manage that process for you. So how does it work? Well, when you log into your Kantan dashboard, At the very top right-hand corner, there's a button called KantanLQR, which you can click on, and you're brought to your KantanLQR projects dashboard. So each of these projects on the screen here are projects that are actually that I've created in my own account. This is my account I'm logged in as. And the way you create a new A/B project to evaluate the differences between a statistical engine and a neural engine is you click on the new project. And in this case here, you simply give the project a name, and then you select from the project type whether it's a quality evaluation project, that's the traditional project, or whether it's an A/B test. So I'm going to select A/B test here, and then it creates that project for you. So my project here is called A/B sample. Now what you need to do is actually add in the test data, the samples that you want to test against. Now you need to add in 3 samples here, guys. The very first sample is your source segment. So these are the segments that, in this example here, it's an English sample. So this example I'm showing here is the difference between Chinese, simplified Chinese. So my English text is entered first. Then I type in my target A, which segments, which is coming from, in this example here, it's from my neural engine. So my output from the neural engine is in target A segments, and target B segments is coming from the equivalent statistical engine. So what we actually did here was we actually compared, using exactly the same data set, our neural engine against its statistical engine, and we wanted to see what the translator selected. Okay, the inference being if they select more from the neural engine, we're making the inference that that actually is a better output, more relevant to what a translator is working on. Okay, so what does the translator see then? When you key in the translator's email addresses and so on, KantanLQR automatically contacts the translators and distributes the projects to them. So they just log into it, basically the Kantan portal, and they actually start evaluating the translation. So in this example here, this is an example with some French translation. So the translator will see the source text appearing at the top of the screen, followed by the 2 sample translations. And in this particular example here, because I speak a little bit of French, they're identical. So the neural engine performed identical to the statistical engine. So in that case there, the translator will select the same button. If one of those was sample A or sample B was better, they'd select better, depending on how they interpret the translation. Now, of course, the cool thing about this is it's all done on the cloud. It's all done automatically. So as the project manager, you get a real-time readout of what's happening in the project. So you can simply go back into the project manager's dashboard, and you can see how the translators are evaluating the translation. And more importantly, we have a data analytics component that actually shows you what sample is being selected more than sample B. So in this particular example here, if you look at the graph at the bottom there, it shows you that target B is actually a better output than engine A. And in fact, and this is a live example here. In this particular example here, this was I think this was the French engine, I think, wasn't it? It was this French engine. 60% of the translation was selected from the neural engine as opposed to the statistical engine. Now, the key thing to remember, guys, is they are the identical engines. One is built with statistical methods. The other engine is built with neural methods. They don't differ in anything else. They're exactly the same engines. It's just the way we train the engines to produce this large increase in output. So, conclusions. Okay. So, KantanNeural, it's available today. We have 3 language arcs available to all of our clients worldwide. Those language arcs are German, simplified Chinese, and Japanese. So they're available today. We are building, as we talk, we're building more and more engines. We expect to roll out a dozen or so engines in the next couple of weeks. So more and more of these engines will become available to our clients. But more importantly, our clients, as of next week, will be able to take their statistical engines and retrain them using neural technology as well. Okay, so they'll be able to start doing that. Now, I will emphasize at this stage that we're launching this worldwide next week as our beta launch, and that the final release launch of this will be in 3 or 4 weeks after that. So for the next 4 weeks, it will be free for everybody. It will be open access to everybody so they can start experimenting and seeing the improvements for themselves. In addition to that, we have the A/B testing available today. It's available to all of our clients free of charge, and that now gives you the tools that you need to really evaluate how your SMT engines compared to your neural engines. And that's really important because remember, with the introduction of a new technology like this, we've got to build confidence in the technology in understanding how better it is or how better the outputs are. And hopefully KantanLQR with its A/B testing component will now help you guys be able to manage that process and get a better sense of how these engines will improve the translation overall. In terms of KantanNeural, it will be available next week. You can build your own neural networks. It will be completely adaptive NMT, which means when you start building your own engines, we will give you a base engine on which we will add your data to, and that will adapt that engine. So you don't have to start with hundreds of millions of your own words. We will give you a starter engine, or what we refer to here as a baseline engine in your language combinations. We will be launching the API for KantanMT very shortly. I think that's in 2 weeks' time or maybe 3 weeks' time. And then we'll be actually increasing our fleet of GPU machines in order to improve the training time of NMT engines. So we hope this is good for you. It's certainly been a great project for us to work on. It's really exciting times. The industry is going through a revolution and change at the moment, and we're delighted that we've been able to bring this technology to our clients super quick so they can start early in the technology adoption curve of neural MT methods. So thank you very much for your attention today. With just 18 seconds to go on our time frame, so we're actually bang on target, which is fantastic. And we'll now hand it back to Palumi, who has some questions, I believe, for us. Yes. Thank you very much.
Thank you. Thanks, Tony. Thanks, Dimitar. We are doing great for time, so we are ready to take a few questions. You can type in your questions in the question box. Sorry about that. So the first question that we have here is, probably Tony, you'd be able to take this. Could I ask how KantanNeural differs from other neural MT competitors in the market right now?
Okay, and it's a very good question. And we took a slightly different approach in the development of neural MT because there's a number of people have actually beaten us to the market with neural MT. So for instance, Google, we all know Google have been there. We know Bing is there in a number of language combinations. I think Bing have about 8 language combinations available in their try and compare interface. And then Systran have done extraordinarily well in getting to the market with several test engines as well. I think they've something like 12 test engines, if I'm not mistaken, off the top of my head. But none of them have been able to deliver a system where you could customize and adapt your own MT or neural MT engine. And that's the approach we took. Because of the modular nature and the highly distributed nature of the Kantan platform, it was relatively quick for us to take Tiano, which was the first system we used, and embed that into our framework. In fact, it happened pretty much in a matter of weeks. And then we decided, hey, let's compare this to OpenNMT. And in the space of a fortnight, we were able to switch everything to OpenNMT and just have a super fast delivery. And that really brought us to the point where not only could our clients use NMT, because we do have NMT engines available for the last couple of weeks, now they can, more importantly, experiment with building NMT engines. And that's a key thing that we have to deliver to our clients. The vast majority of the Kantan clients today customize and adapt their own systems. So it's not good enough for just us to deliver the use of NMT engines. They need to be able to customize, train, and adapt their own engines. So that's the difference of approach that we've taken.
Right, Tony, I think the next question that we have is kind of coming from the same place. So when you said that the neural engines can be adaptive, do you mean that when the post-editor's correction can be given in and fed back to the machine and that comes out?
Okay, I'll take that question. Actually, it's interesting because we do have a technology on the Kantan platform called ISR, Kantan ISR. ISR stands for Instant Segment Retraining. And that allows you to post back, even on statistical engines, you can post back translations, and within, I think it's 5 or 6 seconds per segment, that engine will adapt immediately to the introduction of that new segment. Now, we don't have that working for neural at the moment, so I guess you can't really call it fully adaptive in that sense. But because it's built on the Kantan platform, and ISR is an integral feature of the Kantan platform, it won't be long before we connect ISR into neural engines, but it's not there available at the moment.
So it's a future development.
Future development, yeah.
Okay, thanks, Tony. And the next question here is, will it take me longer to translate with KantanNeural engines than your usual SMT engines? Dimitar, would you want to take this?
Well, that's indeed an interesting question, given that we're speaking about how neural networks require much more computational power to be trained to. Well, with our experiments, what we have seen is that, of course, we have tested both GPU and CPU options. With the OpenMT system, basically the time is pretty much the same as with SMT. So when it comes to GPU, we have pretty much the same time for translating with NMT than that with SMT. When it comes to CPU, it is a bit slower, of course, but we were very surprised and heavily surprised to see that indeed the time is really close. And to be honest, I don't think that our clients will see much of delays when translating on CPUs.
Okay. All right. Cheers, Dimitar. That's brilliant. There are a couple of more questions. I'll quickly take these. One of the questions is regarding, is there any automatic score that might better reflect the quality of NMT than, I suppose, blue score that you were just talking about?
Okay, that's a very interesting question. I guess between myself and Dimitar, the jury's kind of still out on that. Although, if you look at, I think, well, let me step back. I guess in terms of blue is a non-starter, because we've seen in our own testing that low-scoring blue segments from an NMT engine could be very, very valid translation. And it's almost like the neural NT engine has understood the sentence that it's translating, so it gives you an equivalent translation for that deviates substantially from the reference translation, but nonetheless is still a very, very good translation. You saw it in the example I displayed in one of the slides earlier on. So blue is gone. Now, blue is not suitable, I guess, in terms of NMT. I guess we need an N-blue, a neural blue score of some sort. TER can be an interesting score, but again, because TER calculates the number of insertions, removal, insertions, substitution, and deletions of characters. It can be a useful score, but again, it degrades in low-scoring blue. You get a high TER score for segments, but it could be still valid translation. So TER is suitable to a point, but it doesn't cover the full spectrum. And I think there's lots of research papers announced to look into this, but I don't think we've seen any that has landed a proper solution for this. And maybe, at the moment, is it character-based comparison versus word-based comparison might win out at the end of the day. Maybe that's the way to go. But we certainly haven't got an automated score for measuring NMT, and that's the reason we built KantanLQR and introduced A/B testing, because at the moment, the only true benchmark for comparative analysis is professional translators. They're the guys that have the ultimate say in this.
Okay, thanks, Tony. I will ask you 2 questions, but we need to be really quick about this.
Sure.
How much data do I need to train an NMT engine? 300,000 K translation unit or 1 million? How much data? 300,000 K.
Okay, I guess the best way to answer that is to give you a sense of the engines that we have publicly available on the Kantan platform. We have 3 engines at the moment, and the German engine is trained on 8 million segments. The Japanese engine is trained on, is it 11 million and 15 million on Chinese? We can correct those if I'm wrong there after this presentation. It's in that.
15 is the German, and then 15 million is the German, then the rest are 8 and 11.
Oh, I got them the wrong way around, guys. There you go. So my apologies there for misleading you. So they're the amount of segments that we built. Now, the reason we use such a high number of segments there is because we ran the training using even though we knew there was a deficiency in blue, but we wanted to achieve a similar blue to our statistical engines, okay? And we wanted to use exactly the same data set. Now remember, this is really important. We wanted to have exactly the same SMT as NMT in terms of how we train those engines, and we even used the same test reference set to calculate our deficient automated scores as well. But it gave us a benchmark in development which we then used with professional translators to do A/B testing. Okay, so we're going to we've got some kind of nice, exciting results that we'll share with you later on that. But that was the way we approached that. So, you know, can you do with less training? Yes, you can. It's quite incredible, guys. It blows your mind when you start using this technology. Gone are the days where you need massively large data sets. You can actually build a particularly good domain-specific engine with quite a small data set. It's quite remarkable what these things can do.
Okay, and one last question, Tony, thanks, is once the beta phase is complete, what's the cost going to be to access an NMT engine?
I knew somebody would ask me that question. That's always the question. Okay, so show me the money, I suppose, is the question there. So during the beta phase, which will be for the next 4 to 6 weeks, we're going to provide it free of charge to all of our clients worldwide. Okay, so there is no charge for using NMT. But obviously the operational cost of running an NMT system, because you're using GPU systems versus CPU, and there's a significant difference in cost there, there will be additional charges. So, and you know, we've always introduced new technology like this. We've said, look guys, just use it, see what you think, give us the feedback, and we'll improve it with the input from our clients. That's the very design policy we chose when we developed the original platform. And then we'll introduce a cost model for it. What is the cost model? To be honest, guys, I do not know. You know, we're so excited with the technology development at the moment. We actually haven't sat down and talked about the pounds and shillings yet, you know, but we will do that at some stage.
All right, brilliant. Thanks, Tony. And thank you, everyone, for attending this webinar. If you have any questions about KantanNeural or about A/B testing, do mail us at info@KantanMT.com, or for a demo, mail us at demo@KantanMT.com. And have a great day ahead. Thanks. Thank you, guys.